6,000 to 10,000 employee, the Space Center is managing by Caltech, and then is funding by NASA. The place is called Jet Propulsion Lab, JPL. What does JPL do? Initially, it's developing the rocket propulsion. Okay, one is for the mission of the weapon. Another mission is putting the. Another thing is we try to go to the moon. Lately, there's a good news about the moon is there's a water there, so maybe we can somehow move there. So the rocket propulsion is a very important technology because for a long time, United States making a lot of money is by putting the satellite onto the orbit. Lately, of course, Chinese technology catch up. Japan is the technology for picking up, or even Korean is picking up. So from the people who stay in the United States, you have to find out where I can go to get a job, where as an engineer. Of course, now Google is very good, right? Apple is very good. But remember, majority of those people, iPhone, or even the BlackBerry, they are all made in China. But because of their invention, they make a killing in the profit. Maybe BlackBerry right now, they manufacture this in Shenzhen or Taiwan. The whole thing is only cost about less than $100. But when they're selling to the United States, it's $500 retail, right? Some of them sell 500, some 400. So they make a lot of profit because what we call it, the patent right and so forth. So United States maybe is going to patent right. So in these cases, the same thing with the jet propulsion, rocket propulsion. So what will United States to do? There's a lot of people say we got to break through on this. One is green energy, and the second thing a lot of people is dreaming about is put somebody to travel in the orbit, right? So how many people can afford? Oh, Chinese can afford a lot of things. So what does a rocket do? So first, a rocket is a fuel. So if we go up, it's a rocket. So they have a fuel injection. Keep pushing this. Each particle, each gasoline particle or fuel particle push down. When it's pushing down, it's creating a thrust pushing it up. Okay, so that is where the thrust comes from. So that's my turbo engine does. Okay, so we like to all this is used the things we develop is using by what we call by JPL energy engineer. They call first cut. So all the basic things you learn in the first year and second year college education are the most important education in your life. So what the physicists do after you finish first year and second year, all those are math. Okay, what does what we call mechanical engineer do? Is the rest is all math and more higher math. That's all. But when you come to practice, the first 2-year physics, first 2-year chemistry, first 2-year math are most important. That's where when you go out to work, that's where you base upon. Okay, so that's why when you go through MCAT, they test you first 2-year science class. When you go to DOT, first 2 years science class. Do you take the optometry OAT, first 2-year science class. Okay, that's all. You know, say the least, the first 2 years in your college education are the most important part, and then the 3rd year and junior year and 4th year and stuff is important for your career, but all the things you have to learn in there. For example, when I go on the graduate school for physics degree, the teacher to teach me oral exam or the written exam had to go through the first 2-year physics class. They don't test me the 3rd year and the 4th year physics class. Okay, so that's how important that is. So now we figure out the momentum. So we from the top we know that a change of momentum we are creating impulse. Impulse that have an ingredient called force times delta t. So we like to figure this out. So we draw a diagram in here. So first of all, this first it should have a velocity v traveling, and this one carry some field. Delta m is the field. So the initial momentum is equal to, in this case, is equal to m plus delta m times v. Okay, so now we have something is ejecting out, come out. So there's something come out. That is delta m come out. And this is the m moving forward. And in this case, it changed the velocity because that delta m go down there plus delta v. So in that cases, we like to say what is P sub f. P sub f equal to m times v plus delta v, and then plus delta m, but there's a v minus v sub e. So again, if you equal them, the conservation of momentum P sub I is equal to P sub f. So again, is using simple algebra for solving this problem. And then this is equation 1, equation 2, and then you simplify. So m times v, this is m times v, you cancel out, then what is left is you have m dv, or m delta v, is equal to minus v sub e dm. dm basically is considered delta m, small m. So from this, you basically you have the things that we like to say. You integral v sub I to v sub f is equal to minus v sub e integral mi mf dm over m. So after all that is done, then you have a v sub f minus v sub I equal to v sub e log m mi divided by mf. That is the basic equation. This is the basic equation for rocket propulsion. Now, in the example 8.14, we're using this to do the calculation of the final velocity, and then finally using this to calculate the thrust, in which case the force of pushing upward. So the chapter 8 is finished. Sorry about so rush, but chapter 8 we already mentioned that couple problems for you to do. Number one is the conservation of the momentum for collision, in which cases is on the page 235. Please study this. And then as far as our homework goes, is useful homework for you to study is number 41, number 39, number I think is 33 and number 27, and 16 and 15. Only 6 questions, and for you to responsible for the second midterm. But when the midterm comes, I will do more narrow down the thing for you to study. So chapter 9 is reserved for the relativity. It's reserved for Physics 31B. So now we go to the chapter.